One. So, in the last class, we seen about the electromagnetic wave. So, how the electromagnetic wave is formed? So, actually, it is formed by the vibration of electrical charges. Vibration of electrical charges. Due to the vibration of electric charges, it creates electric field and magnetic field. So, these two are perpendicular to each other and these are right angle to the direction of propagation of wave, right? So here the wave means it is characterized by two parameters mainly. The two parameters are wavelength and frequency. Wavelength and frequency. These are the two parameters which mainly characterize the wave nature. So first of all, we can see about the wavelength. What is wavelength? Suppose if you are consider like this is a wave. This is a wave. So in this wave, this is called as mean position. These are called as mean positions. The particles are displaced from the mean position to maximum. This is said to be, this part is said to be crust. This is said to be crust. And the lowest position, the lowest displacement from the mean position is said to be trough. Right? So crust and trough. These are the two positions, and here it is also said to be crust. This is also said to be trough. So like that, crust and troughs are formed in a wave. Right? So then what is wavelength? Wavelength is nothing but the distance between the two adjacent crusts or two adjacent troughs. The distance between the two adjacent crusts or two adjacent troughs are said to be wavelength. So actually wavelength is denoted with the symbol lambda. Wavelength is denoted with the symbol lambda. So this is said to be wavelength, and this one is also said to be wavelength, because wavelength is stated as the distance between the two successive crusts or two successive troughs. It is said to be wavelength, right? So the units for wavelength are generally centimeters, meters are taken as the units for the wavelength. And along with this, these wavelengths are very small distances, very tiny distances. So that's why we use a small unit in wavelengths. So that is nothing but angstrom unit. Right? 1 angstrom unit is equal to 10 power minus 8 centimeters or 10 power minus 10 centimeters. 1 angstrom unit is equal to 10 power minus 8 centimeters or 10 power minus 10 meters. Right? This is about the wavelength. What is the wavelength? Wavelength is nothing but the distance between the two successive crusts or two successive troughs are said to be wavelength. Right? And second one is frequency. Frequency is nothing but, suppose in this wave, let us take, this is a reference point. What is this? A reference point is taken. To this reference point, the number of waves are passing. A wave is considered, actually wave is nothing but a complete crust and a complete trough. A crust and a trough. Both are combinedly forms a wave. So here frequency is nothing but the number of waves or the number of wave peaks passing by a given point. The number of waves or wave peaks are passing by a given point per unit time. The unit time is generally we can take as 1 second. Unit time is generally we can take it as 1 second. So or 1 minute also we can take, right? So actually frequency is nothing but the number of wave peaks or the number of waves can be passes through a given point per unit time. It is said to be frequency, right? Frequency is denoted with the symbol nu. Frequency is denoted with the symbol nu, right? So this is about the frequency and wavelength. So frequency units are hertz. Hertz are, it can be taken as 1 by second, or it can be written as second inverse or hertz. So these are the units of frequency. Then what is the relation between wavelength and frequency? So let us see. You can consider one wave A. Let us see, this is wave A and this is the reference point, right? And consider wave B for the same reference point, right? So here what is the wavelength here? Wavelength is short. It has a low wavelength and it has more wavelength. What is wavelength? We are already discussed. Wavelength is nothing but the distance between the two successive crusts or the two successive troughs, right? So here two successive crusts are there. It has the more wavelength and it has the low wavelength. So here wavelength is more and here the wavelength is less and here the wavelength is more. So here shorter wavelength it contains and longer wavelength it contains. Then what about the frequency? Frequency is nothing but the number of waves can passes through a given point per unit time. So here due to the low wavelength or short wavelength, the number of waves passing through this reference point is increases. Due to the low wavelength or shorter wavelength, the number of waves passing through this reference point is getting increases. So here due to the high wavelength, so due to the longer wavelength, its number of waves are passing through this reference point is getting decreases, right? So that's why here what happened, frequency is more and here the frequency is less. So finally here when wavelength is shorter wavelength, then frequency is more. When it has a longer wavelength, its frequency is less. So that's why we can say that nu is inversely proportional to 1 by lambda. That means frequency is inversely proportional to wavelength, right? So by substituting one constant here, so that is nothing but c by lambda. So we can write c is equal to nu lambda. What is c here? C is nothing but speed of light in vacuum. Its value c is equal to 3 into 10 power 8 meter per seconds. So this is the relationship between the speed of light and frequency and wavelength. So this is the main relationship here, c is equal to nu lambda. Is this relation is applicable for the sound waves? This relation is applicable for the sound waves? Yeah, absolutely. It is the universal equation. It can be applicable for all the waves, right? C is equal to nu lambda. What is the relation between lambda and nu? that means frequency and wavelength, it is inversely proportional. So C value is, C is equal to 3 into 10 power 8 meter per seconds, right? So this is about the wavelength. And you have seen that in the rainbow there are 7 colors are there. That means each color has its own wavelength and frequency. That means there are 7 colors are there and the 7 frequencies are there. So the entire range of these frequencies are said to be visible spectrum. Right? So this will be discussed in the next class. Thank you.